The golden ratio is an ancient and mysterious mathematical concept that originated from ancient Greek mathematics and has been widely applied in art, architecture, nature, and scientific research. The definition of the golden ratio involves a specific proportion, which is considered particularly beautiful and captivating, hence it is also known as the golden ratio. In mathematics, the golden ratio refers to dividing a line segment into two parts in such a way that the ratio of the whole segment to the longer part is equal to the ratio of the longer part to the shorter part. It is a over b equal to a plus b over a, and it is called phi. Phi is the golden ratio, typically approximately equal to 1.618, also known as the golden number or golden proportion. In history of golden ratio, the origins can be traced back to the era of ancient Greek mathematicians such as Pythagoras and Euclid. In antiquity, people discovered the importance of the golden ratio in aesthetics and architecture, thus it became one of the fundamental principles of ancient Greek architecture and sculpture. In ancient times, people observed many phenomena exhibiting the golden ratio in nature and artworks. For example, the arrangement of leaves in plants, the structure of flowers, and the proportions of animal bodies all demonstrate the marvelousness of the golden ratio. These discoveries further enhanced people's understanding and appreciation of the golden ratio. During the Renaissance period, artists and architects rediscovered the aesthetic principles of ancient Greece and applied the golden ratio to architectural design, painting, and sculpture. Renowned Renaissance artists such as Leonardo da Vinci and Michelangelo utilized the golden ratio principle in creating their works, making them more appealing and harmonious. The golden ratio can be geometrically constructed using a simple method. Here's a step-by-step guide to constructing the golden ratio. Starting by drawing a square. Locate the midpoint of any one side of the square by bisecting it. Connect the midpoint P to a corner of the opposite side. Place the tip of the compass on P and set its width to match the distance PC and draw a large arc towards the side BC. Extend the side AB to cut the arc at some point. By following these steps, you can construct the golden ratio on a line segment geometrically. This construction ensures that the ratio of the longer portion AB to the shorter portion BQ is equal to the golden ratio phi. The application of the golden ratio in ancient Greek architecture is a fascinating aspect of its design principles. Ancient Greek architects, such as those responsible for iconic structures like the Parthenon, often incorporated the golden ratio into their designs to achieve aesthetic harmony and balance. For example, the ratio of the width of the temple to its height often approaches the golden ratio, contributing to the perceived beauty and balance of the structure. Columns were spaced in such a way that their diameters and intervals adhered to proportions derived from the golden ratio, creating a visually pleasing rhythm and symmetry. In contemporary architecture and design, the golden ratio remains a popular design principle. Many architects and designers utilize it to create works that are aesthetically pleasing and harmonious. Some modern buildings incorporate the golden ratio into their facade design. Architects use the golden ratio to determine the size and placement of windows, doors, and other decorative elements on the facade, creating an exterior that is visually appealing and balanced. The golden ratio phenomenon in plant growth refers to the characteristic features observed in many plants during their growth process that align with the principles of the golden ratio. The structure of flowers in certain plants also demonstrates characteristics of the golden ratio. For example, the number and arrangement of petals may conform to the golden ratio, enhancing the beauty and symmetry of the entire flower. Some animals' body structures also demonstrate features of the golden spiral, like the shape of a snail's shell and the growth patterns of horns. The most remarkable are natural meteorological phenomena and celestial phenomena. They both exhibit characteristics found in the golden ratio. The shape of the Milky Way also resembles a golden spiral. It's fascinating to think that we live within a snail's shell. The golden ratio is perceived as a natural and harmonious proportion, found in many aesthetically pleasing objects and structures in nature and art. Its balanced and symmetrical properties evoke a sense of visual harmony, making it appealing to the human eye. Certainly, the Mona Lisa painting by Leonardo da Vinci is often cited as an example of the golden ratio's aesthetic appeal. The proportions of the Mona Lisa's face, particularly the placement of her facial features and the overall composition of the painting, are believed by some to adhere closely to the golden ratio. This harmony and balance in the composition contribute to the painting's timeless appeal and its status as one of the most iconic and recognizable works of art in history. I'm curious about this as well. So, I'd like to commission an artwork based on the golden ratio, but since I'm not skilled at drawing myself, I've entrusted the task to an AI software. Let's see how it turns out. It looks good. I'm not sure if it's drawn based on the golden ratio, but I think it can still produce great artwork even without needing the golden ratio. In traditional art theory, human body proportions are often believed to be determined by the length of the feet. According to this theory, a person's height should be approximately 1.618 times their foot length, which corresponds to the golden ratio. Therefore, in sculpture design, sculptors often design the proportions of a figure's body to adhere to the relationship between foot length and upper body length that approximates the golden ratio, in order to enhance the sculpture's aesthetic appeal and visual attractiveness. Mathematical exploration of the golden ratio involves various fields including geometry, algebra, number theory, and more. The golden ratio can be expressed using algebraic equations. By solving quadratic equations or utilizing the definition of the golden ratio, mathematical expressions for the golden ratio can be obtained, allowing for deeper exploration of its mathematical properties. Golden ratio in continued fraction and square root. Another interesting feature are related to the Fibonacci sequence. The ratio of consecutive terms in the Fibonacci sequence approaches the golden ratio as the sequence progresses. Specifically, as you take larger and larger Fibonacci numbers and divide each term by its predecessor, the resulting ratios converge to the golden ratio phi. What are your thoughts on the golden ratio? Feel free to leave a comment below. You might even find the golden ratio useful in your artwork. And finally, don't forget to like the video and subscribe to my channel. Bye.